Here are your solutions to 7-6. We'll start with the letter problems. Letter A. It asks us first of all to graph MNO. And the first thing I'm going to do is turn the answers on here. And now we'll just go through this. First of all, I'll point out that I'm not going to graph each of these points. Make sure you check yours and make sure everything is in the right spot. I suspect that everybody understands how to graph by now, so I'm not going to actually spend the time to do that. But then it asks us to write a proportion comparing the rise of the run for each of the similar slope triangles. So if we're going to compare rise over run in the smaller triangle, the rise would be MO, and you see that right here, and the run would be NO, and that's right here. Then in the larger triangle, we have a rise of PR, that's right here, and we have a run of QR, that is right here. And again, we can take a look at that and put numbers on those. So in the blue, we would have a rise of 1 and a run for NO of 2. And then we would look in the green, we would have a rise of 1, 2, 3. So we'd have a rise of 3, and we'd have a run of 1, 2, 3, 4, 5, 6, a run of 6. And in both cases, you would see that that equals 1/2. And that's where this comes from. Okay, letter B, they tell us the plans for a teeter-totter are shown at the right using points G and L. Find the slope of the teeter-totter. So if we use G and L, we're going to rise from here to here, and we're going to run from here to here. So our rise is going to be 2, and our run is going to be 2, 4, 6. Our run is going to be 6. Then verify that the slope is the same at a different location by choosing a different set of points. So we went from G to L, and we had the slope of 1/3. So let's switch and go from H, just H to L. So from H up and over to L. From H, the rise there is going to be 1, and the run from H to L is going to be 1, 2, 3. So we can see that our slope there is 1/3. So we have a slope, so you should write it as M. Remember, slope is designated by the letter M. M is 1/3 from G to L, and it's also 1/3 from H to L. And I'm not real concerned about how you put that as long as you verify that you get the same slope in either case. Here are your solutions to 7-6, guided practice. Problem number 1 asks us to graph. So once again, I'm going to do this the easy way and turn the answers on here. So first of all, we graph the two triangles, and they're right here. So we're going to start with GA and GC. So we have from G to A is our rise, and you can see that it's from -2 up to +4, so that looks like it's a rise of 6 to me. And a run from here to here is a run of 2. So we have 6/2, which of course equals 3/1. But remember, since it was a drop, since you can see that it's going downhill, remember that this was technically a drop of negative. So we should have -3. They've got an error here. There should be -3/1 right here. Because remember, we have a downhill slope here. For FB and FC, we would have a rise from F to B of -3 and a run obviously of 1. So we have -3/1, and in both cases we end up with a slope of -3. Problem number 2. Plans for a set of stairs are shown below using points X and Y. So let's use those two first, right here to right here. From X to Y, that's one step. We're going to have a rise of 2, and our run is going to be from here to here. That's 3. So our rise to run is 2/3. So we can see that they came up with a slope of 2/3 as well. But then we're supposed to verify that by finding another spot. So let's go all the way from Z to W, and we can draw that here so we can see it. From Z up to here would take us over to W right there. So from Z, if we move up, we're moving up 1, 2, 3, 4, 5, 6 is our rise. And our run is 1, 2, 3, 4, 5, 6, 7, 8, 9. X/9. Divide both divided by 3, and we have the same slope of 2/3. And in this case, it's a positive number because we're going uphill here. Slope is 2/3. And now our essential question number 3. Building on the essential question, how is the slope of a line related to the similar slope triangles formed by the line. And what we could say here, again, this is going to be a lot easier this way, we could say that the ratio of the vertical leg to the horizontal leg of each similar slope triangle formed by the line is equivalent to the absolute value of the slope. So remember that it's a matter of vertical to horizontal, or I would like you to think of this as the ratio of rise to run anywhere on the line is the same. So you can draw two triangles any spot on the line and you will have the same ratio of rise to run. Please do independent practice.